Hello everyone. Today I am going to discuss the sixth problem of AtCoder beginner contest 354, which is useless for LIS. So what is the problem? We are given an integer sequence A of length n. For each t from 1 to n, determine whether a t is included in a longest increasing subsequence of A. Okay. So we are given a t test cases, and in each test case we have one integer n, the length of the array, and all the elements of the array, and we have to print the elements which are included in the longest increasing subsequence. So let's take one example, we'll understand it better. So let's take the first example only. Here only one test case is there, so let me write the test case. So in this test case there are five integers. There are five integers: 2, 1, 4, 5, and 3. So what is the longest increasing subsequence? The longest increasing, I hope you all know, it is the length, the subsequence with the longest length, and which is also strictly increasing. So here the longest increasing subsequence could be either 2, 4, 5, or it could be 1, 4, 5. So which elements are included in the longest increasing subsequence? The element which are included in the longest increasing subsequence are this: 2, 4, 5, and also 1 is also included. So the indices which are included in the longest increasing subsequence is nothing but 1, 2, 3, and 4. 5 is not included in any of the longest increasing subsequences. So our answer will be 4, 1, 2, 3, 4. So let's check the answer. Here you can see the longest increasing subsequence. So answer is 4, 1, 2, 3, 4. Okay. I hope you get it. So let's think about some brute force solution in our observation section. So what brute force solution we can think of? The brute force solution we can think of is that we will construct all the longest increasing subsequence. Okay, we will construct each and every longest increasing subsequence, and we mark the indices accordingly. So for this 2, 4, 5, we will mark the index 1, 2, 3 here, and for this in longest increasing subsequence, we will mark 2, 2, 3, sorry, this is not 1, 2, 3, this is 1, 3, 4, and here it is 2, 3, 4. I hope you get it. So after all the subsequence we have visited, all the longest increasing subsequence we have visited, all the elements which are included in those longest increasing subsequence will be marked, and we can print the answer according to the marked indices. Okay. So what is the time complexity? The brute force, absolute brute force time complexity is we have to iterate over all the subsequences, which is order of 2 to the power n, and we are iterating over all the subsequences. So overall time complexity of the brute force solution is order of 2 to the power n into n. Now further, the time complexity could be optimized for this algorithm itself. So I think it could be solved in some, like, something better approach, the brute force solution. But here the constants on n is what? Here the constants on n is 2 into 10 to the power 5, and sum of n is also 10 to the power 5. So overall time complexity could be either order of n, or could be either order of n log n or n log square n also possible. So this possible time complexity is order of n and order of n log n. So this approach is definitely not acceptable, and any optimization will not go from 2 to the power n into n to order of n log n. So how we can solve this problem? So let's think about the possible approaches to solve the problem. So here you can see that we can build two types of array. One is prefix I, and another one is, sorry for that, I had a call. So now what I am trying to say is that let's consider two arrays. One is prefix and another one is suffix. So what the prefix I will give us? So prefix I will give us the length of the longest increasing subsequence ending at the current index. So prefix I will give us the length of the longest increasing subsequence ending at the current index, and also the current element is included. So let's try to construct the prefix and suffix array from this array 2, 1, 5, 4, 3. Now for prefix array, only first element is would be included if we consider prefix of 1. So the answer for prefix of 1 is 1. Now for the prefix 2 and to be 1 to be included, the length will be 1 again. Okay. And for 2, 1, 4, this prefix and including 4, the longest increasing subsequences could be 2, 4 or 1, 4. So the length will be 2. For 2, 1, 4, 5, the longest increasing subsequence could be 2, 4, 5 or 1, 4, 5. So it is 3. Now here, when we are considering the entire array, Here you can think the longest increasing subsequence is 3, but we have to include this value 3. So when you include the value 3, the longest increasing subsequence would be either 1 3 or 2 3. So it will be 2. Okay. Now let's consider try to construct the suffix array. Okay. Suffix array means that longest increasing subsequence in the suffix. So for longest increasing subsequence on considering only 3, only this value will be 1. Now considering 3 5 3, it is also 1. 4 5 3, the longest increasing subsequence is 4 5, so it is 2. Now 1 4 5 3, the longest increasing subsequence is 1 4 5, which is 3. Similarly 2 1 4 5, the longest increasing subsequence is 2 4 5. When we are considering suffix I, we have to include the current element ai. Okay, so we have built the prefix I and the suffix I. Now my solution is that if prefix I plus suffix I minus 1 is equals to the longest increasing subsequence of the entire array, then we have to include the current element. Why? Because what we are saying is that prefix I means that there would be something like x1 x2 and then ai. Okay, and suffix I means that from ai till x of lis minus 1 and x of lis. Okay, kind of that. Okay, so the total elements in the array is prefix I plus suffix I. Now ai is included in both of them, so we have to add prefix I plus suffix I, and we have to subtract minus 1 from here. Now what I am trying to say is that if the length of these are this set and this set are exclusive, right? Only ai is common between them, so if we join them, if we merge them, then we will get our longest increasing subsequence. Now if the length of this two sequence, merging these two sequence is the longest increasing subsequence of the entire array, then this element is to be included, otherwise the element is not to be included. Okay, so the after prefix and building the prefix and suffix array, the entire part is quite straightforward. Now how to build this prefix and suffix array, that is one important thing. So how we can do that, how we can do that? So let's jump into the some solution to build the prefix array first. The suffix array is similar, so I am not going to explain that. So let's try to build the prefix array. So for building the prefix array, what will we take? We'll take one so let's jump into the implementation details later. So now let's say we have 2, and now we are trying to add 1. Okay, now for 1 we will try to say check what is the maximum value, maximum increasing sequence value, which is less than 2. So there is no subsequence less than 1. Okay, less than 1 here. So the longest increasing subsequence is 0. So we'll add 0 plus 1 here. Now when we are trying to add 4 here, now we'll try to check which the longest increasing subsequence which is less than 4. So here the longest increasing subsequence less than 4 could be only 2 or 1. So the value will be 1 plus 1 2. Okay, so when we are trying to add 5, so the longest increasing subsequence are nothing but 2 4 and 1 4. So the length of the longest increasing subsequence is 2, so it would be 2 plus 1. Similarly for 3, we'll check what is the length of the longest increasing subsequence less than 3. So the subsequence is 2 or 1. So the value will be 1 plus 1 2. I hope you get it. That's how we are constructing the prefix array. Now for checking what is the value less than ai, maximum value less than ai, we can use some range based data structure like segment tree. Okay, so I am using segment tree here because prefix some will not help, sorry, prefix array will I think be not possible because we are updating dynamically. So we are using two segment trees, for one for suffix and another one for suffix. Now I will jump into the code and I will try to explain each and every line. Okay, so let's jump into the code. So here, let me close this. This part is for the segment tree. I have explained this part in my previous videos also, how we are building the max segment tree. Okay, I am not going to explain this, so you can search about segment tree and read any article. Okay, now we are taking two segment trees. First seg is for prefix and seg2 is for suffix. Okay, now another important thing is that ai is 10 to the power 9 and we are trying to search what is the value from 1 to ai minus 1. Now we can't construct a segment tree of 10 to the power 9, right? So for that we have to do coordinate compression. Now what is a coordinate compression? Coordinate compression, let's say we have some values, let's say 10 100 1000 and 10 to the power 4. Okay, now what we can do, we can map these values, we can sort these values. These values are already sorted, right? Now we can map this value to 1, this value to 2, this value to 3 and this value to 4, right? Now let's say there are two similar values. Let's say we have 10 10 20 30, and let's say I have 5 1. Now after sorting, this will be like 5 10 20 and 30. After sorting this and removing duplicates, so we'll map 5 to 1, 10 to 2, 20 to 3, and 30 to 4. After the mapping is done, we'll mark this value. So this will be 2, I think it will be 2, this will be 2, 20 will be 3, 30 will be 4, and 5 will be 1. So our final array will be changed from this to this. So why this will help us? Because we are reducing all the values of AI to from 1 to n. Okay, we are reducing all the values from AI from 1 to n. I hope you get it. Now this part is for the coordinate compression. For coordinate compression, we are inserting all the elements in a set. This will remove the duplicates. Now we will iterate over the set and mark the mapping of the set element to the to one index. We will initialize c with 0, and we are incrementing the value of c after marking one value. And this part is for changing the AI to mapping of AI. So this part is for the coordinate compression. There are three steps. First, insert all the elements in the set, then mark the set values to a specific mapping and change the value of AI. Okay, I hope you get this coordinate compression part. Now this part is for building the prefix array, this part is for building the suffix array, and this part is for checking that if the prefix I plus suffix I minus 1 is the longest increasing subsequence or not, and if yes, then we are inserting in the set. Now for checking that, we are doing query from this particular index 1. We are checking what is the maximum value from 1 to AI minus 1, okay, for prefix. And we are adding 1 here also. Okay, we are adding 1 here because let's say for this 21453, so we'll check all the values. What is the maximum value from range from 1 to 3, and the value is 1, so the longest increasing subsequence will be 1 plus 1 2. I hope you get it. And after that, we are marking prefix I as answer, and we are updating the value of answer to our current index AI. I hope you get it. Now for suffix, the part is also similar, but instead of checking from 1 to AI minus 1, we have to check from AI plus 1 to n. AI plus 1 to n. Here n could be the number of distinct elements in the set. Okay, so that's why what I am doing, instead of searching from 1 to AI minus 1, I am searching from AI plus 1 to C. Okay, now the rest of the part is quite straightforward, and instead of making another function to compute the LIS, I am taking LIS as the maximum of the suffix array. Okay. I think I have explained every part of the code, and I have also explained what is my approach and observations. If you find any doubt in any part of the explanation, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel, and also share among your peers. Thank you.